An important skill in this section of the course will be converting between the different types of structural formulas. So for example, I could give you a problem where I say, draw hexane in line angle, expanded, and condensed structures. So I'm going to take hexane. The prefix hex tells me that there are 5 carbons in the formula, and the ending ane tells me that it's an alkane, which means that it has only single bonds. Drawing the line angle formula is really nice because all I need to do is draw 6 dots and connect them. So I will draw 1, 2, 3, 4, 5, 6. And I'm going to connect all of these in a zigzag pattern. And that will give me the structure of hexane in a line angle format. And it might help to go through and kind of number the carbons so you can keep track of what atom is where. Now, when it comes to converting between condensed and expanded formulas, I think it helps to go into expanded first and then collapse it down into a condensed formula. So I'm going to do that next. I'm going to take this expanded structure, this line angle structure, and I'm going to expand it out. So I will copy this over. And you can draw the carbons right on top of the structure if you'd like. So I'm going to just doodle in carbons in all of the corners where they're supposed to be. Alternatively, what you could do is, if you don't really like this zigzag pattern, you could just draw 6 carbons in a line and go from there. Okay, so let's continue with both. If I look at this carbon right here, I notice that it only has 1 bond, which means that it needs 3 more bonds to have an octet. So I'm going to give it 3 hydrogens. And I could do the same thing on the linear version of that below. Notice that this carbon at the end is the exact same type of carbon. It has 1 bond, which means it needs 3 hydrogens to complete its octet. This carbon contains 2 bonds, which means it needs 2 hydrogens to complete its octet. And that is the same scenario for every other carbon in the middle of the structure. So this carbon has 2 bonds, which means it needs 2 hydrogens. Same with this carbon. And same with this carbon. And that takes me into my expanded structure of hexane. To turn that into a condensed structure, I can start collapsing these down. I notice that at the end, I have a CH3 unit, so I'll write that as CH3. The unit next door is a CH2, so I'll write that as CH2. Maybe I'll keep these circled. There we go. The unit next door is also a CH2. And I'm just going to go down the line and draw all of these CH2s until I get to the end of the molecule. And when I get to the end, I find that there's another CH3 unit. So I can leave that as a CH3. And that is my condensed structural formula. So I think it helps to start with the line angle, first expand it out fully so that you can see all of these CH2 units in between, and then convert it into a condensed structure. Let's try another problem. Let's do the same process for butane. The prefix but is telling me that there are 4 carbons in the structure. The ending ane tells me that it's an alkane. So I'm going to start with my line angle structure, which is also called the bond line. I use these terms interchangeably. And I need 4 carbons, so I'm going to draw 4 bonds. And each of the corners here represents a carbon. Then I'm going to turn that into an expanded structural formula where I'm going to represent these carbons as C's and connect them with single bonds. So these are the 4 carbons that we had in our expanded structure. Notice this first carbon only has 1 bond, so it needs 4 more bonds to complete its octet, and I'm going to populate that with hydrogens. At the very end of the structure, I have the same type of carbon that only has 1 bond, so I'm going to give it 4 more bonds to complete its octet. And the carbons in the middle contain 2 bonds, which means each one needs 2 more hydrogens to complete its octet. And that's my expanded structural formula. Next, I can condense that down into a condensed structural formula. I'm going to start by collapsing this unit down into a CH3 unit, and I'll connect that to the next carbon. The next carbon has a CH2 unit. The carbon next to that has a CH2 unit. And finally, I get to the end of the chain, which is another CH3 unit.